Let's imagine a beaver sitting up high on a hill. From out there he can see everything, the landscape, the weather, even potential dangers. Because of his great view he has access to all kinds of valuable information. But his beaver friends living down below don't have that perspective, they can't see what he sees. So they all came up with a clever idea for how to share that information. Whenever the beaver on a hill notices something important, he writes it down on a piece of paper. Then he rolls it up and puts it into a bottle and drops it into a nearby stream. The current carries the bottle downstream where another beaver is waiting. His job is to collect these messages. This beaver takes each bottle, reads the message and puts it neatly on a shelf. Now whenever another beaver, let's say his name is Bob, wants to know what's going on, he makes a special sound that includes his name, Bob. When the message keeper hears this, he finds the right message, makes a copy and sends it down the stream to Bob. But here is the smart part. Once Bob gets a message, the keeper writes it down, so next time Bob calls out, he won't get the same message again. He will get only new messages. Now if another beaver comes along, maybe his name is Kevin, and sends his signal, he will get the early message that Bob already read. And from that point, Kevin will also get only the new messages. So in the end, every beaver gets each message only once and never the same one twice. Now, believe it or not, this is actually very similar to how Kafka works. In the world of Kafka, we also have a system made up of 3 key parts, just like our beaver story. First, there is the producer. This is like the beaver at the top of the hill. He is the one who creates messages and sends them into the stream. In Kafka, the producer sends the messages to something called a broker. The broker is just like our middle beaver who catches the bottles. He stores the messages for a certain amount of time and makes sure everything is organized and ready for others to read. And finally we have the consumers. These are the beavers at the bottom. They call out with their names when they are ready to receive messages. Kafka makes sure that each consumer gets only the messages they haven't seen yet, just like in our story where Bob and Kevin each got the right messages at the right time and never the same one twice. So that's the basic architecture of Kafka. Producer creates the messages, broker stores them, and consumers read them when they're ready. Now let's take this idea one step further. Imagine there is not just one stream but many. Each stream carries a different kind of message. So maybe stream 1 is all about the weather, stream 2 that's for the safety alerts, and stream 3, well, that one's just for fun facts or jokes of the day. Now the beavers living down below can choose what kind of updates they want. Let's say Bob wants to know what the weather's like. He walks up to the stream 1, sends out his little sound signal, Bob, and the beaver watching over the stream checks his list, sees which message Bob read last and sends him the next weather update. Kafka works the same way. We have different topics where producers send data and consumers read it. Each topic has a name that tells us what kind of data it holds. Let's say we are building a social media app and we want to analyze user behavior. When a user likes a post, writes a comment or creates a new post, each of those actions generates data that gets sent to the Kafka broker. On the other end, our app picks up these messages and reacts accordingly, using them for notification, recommendations or analytics. To make this work, we would create separate topics in Kafka, one for likes, one for comments, and one for posts. So when a user likes something, that message goes to the likes topic. Then different services subscribe to the topic and handle the message in their own way. The notification system sends an alert to the post author. The recommendation engine updates its model based on the like. And the analytics service stores the data in a format ready for analysis. Each service does something different with the same message, and that's the power of Kafka. Let's go back to our beavers for a moment and see what happens to the messages on their shelves. When a beaver receives a message, he writes down the date he got it. Every day he checks all the bottles and asks, has it been more than 7 days since I got this? If yes, he gets rid of it. So in practice, messages are kept for 7 days and then they are removed to make space for new ones. In Kafka we call this data retention. We set how long a message should stay in the broker, for example 7 days. The goal is to find the right balance. not too short, so consumers have time to read the messages, and not too long, so we don't waste the disk space on old, already processed data. This keeps the system clean and efficient. Sometimes there are just too many messages for one beaver to handle, so other helper beavers come in to share the work. Each one takes care of a different group of beavers. For example, Steve handles all beavers whose name starts with B, and Mike takes care of those starting with S. That way messages get delivered faster and everyone stays organized. In Kafka, topics are divided into partitions. Partitions help increase throughput and allow multiple consumers to read messages in parallel. Now let's talk about the ways consumers can read from a topic. The first method is manual partition assignment. In this approach, a consumer is manually assigned to specific partitions. For example, let's say consumer 1 is assigned to partition 0. It will only read messages from that one. It's also possible for one consumer to read from multiple partitions. However, two consumers cannot read from the same partition. Within the same topic at the same time, only one can be assigned. The second, more common way is to use a consumer group. In this setup, Kafka automatically distributes partitions among the consumers in the group. It's simpler and more dynamic, especially when consumers join or leave. Now, how does Kafka know which messages to send without repeating any? Well, as we know, messages in Kafka are immutable, so they are only deleted after a certain time to free up disk space. To keep track of what's been read, Kafka uses something called offsets. Each time a message is read, the offset moves forward. These offsets are stored in a special internal topic called consumer offsets. This topic is managed by Kafka itself, and it stores details like offset value, the consumer group ID, and the partition number. Thanks to this, Kafka always knows what has been read, what hasn't, and makes sure no one gets the same message twice unless they ask for it. Now let's talk about how data is produced. By default, Kafka uses a round-robin method. Messages are sent to partitions in order, one after another, to keep things balanced. But sometimes we want certain message to always get to the same partition. That's where the message key comes in. Along with the message itself, we include a key, and Kafka uses a hash function to determine which partition it should go to. The same key will always be mapped to the same partition. So if multiple messages have the same key, they will all end up in the same partition every time. This is especially useful when we want to keep the order of messages for a specific user, session, or entity. By sending all related messages to the same partition, Kafka guarantees they will be proceeded in the right sequence. I hope you enjoyed and learned something today. Subscribe and see you soon.